Efficiency, what is it? Why does it matter? And how do we calculate it? Efficiency is all about how good a device is at turning the energy that you put into it into useful energy that you get out of it. But not all energy goes into useful energy. Some of it comes out as waste. I've nicked my wife's kettle again. The kettle used energy to heat the water, but not all that energy was usefully transferred into the water. A lot of it was dissipated as heat to the surroundings. The efficiency tells us what proportion of the energy we put in actually has gone into heating the water. Better go make her a cup of tea now. Here's the formula that you need to use for your GCSEs. Efficiency equals the useful energy out divided by the total energy in. This is a ratio and it gives us a number between 0 and 1. As we get close to 1, we get more efficient. As we get close to 0, we get less efficient and more energy is being wasted. You may be more comfortable expressing this as a percentage. That's perfectly okay. To do that, you just multiply it by 100%. So the efficiency as a percentage is equal to the useful energy out over the total energy in multiplied by 100%. Let's break this down. The useful energy out, well, that's the energy that goes where we want it to go, like heating the water in the kettle. The total energy in, that's all the energy going in, and that includes the stuff that gets wasted when it comes out. We multiply it all by 100% to get our percentage. Let's try an example. A light bulb uses 100 joules of energy to produce 20 joules of light. How much energy is wasted and what's its efficiency? Well, the wasted energy is 100 minus 20, which is 80 joules of energy. You can see it's not going to be very efficient. To calculate the efficiency, we first of all have to identify what the useful energy out is, and that's the 20 joules of light. The total energy going in is 100 joules. So we now do our 20 joules divided by 100 joules and times it by our 100%. So we see this light is only 20% efficient. That's not very efficient at all, and most of the energy is wasted as heat. In fact, 80% of it is wasted as heat as it's dissipated to the surroundings. Thankfully, most modern light bulbs are a lot more efficient than this. I could have also written this as a number between 0 and 1, so that would have been 20 over 100, which would have been 0.2. Notice it has no units. Remember though that no device is 100% efficient. We always lose energy as heat and sometimes sound. We're always trying to make things more efficient. That's why we have energy-saving light bulbs and more efficient cars. I'm going to look at how we can improve efficiency. But before that, just bear with me for a second. As always, there are free questions and worked answers to go along with this video, and the link to those is in the description below. Do check out my website for other free resources. I do offer one-to-one lessons for GCSE and A-level physics students on a topic of your choice. To make it a bit more affordable, you could also join a class or workshop of up to 6 students. I try to produce as much as I can for free, and to do that I need your support, so if you don't mind just liking, subscribing and commenting on this video, that'd be appreciated. Right, there are ways that we can improve efficiency. Let's have a look at 4. Number 1, energy can be lost where there are moving parts. We can reduce this by lubricating, and that reduces friction. 2. Air resistance is a force that turns kinetic energy into waste energy. We can reduce this by making shapes streamlined, and that's particularly important for things that move fast, like cars or aircraft. Number 3. Sound and vibrations cause waste energy. We can reduce this by making sure components aren't loose and tightening everything up. 4. Wires that carry electric current can heat up. We can reduce this by making the resistance of the wires as low as possible. To finish off, here's one last example. A wind turbine is 40% efficient. How much energy does it need from the wind to produce 2000 joules of electrical energy? Well, efficiency is useful energy out over total energy in times by 100%. So our 40% efficiency equals 2000 joules of useful energy divided by our energy in times by 100%. So if I multiply the 100 by 2000, I get 40 equals 200,000 over the energy in. If I move the energy in over to the other side of the equation, I get energy in times 40 equals 200,000. So my energy in is 200,000 divided by 40, which is 5,000 joules. Remember to practice, and remember there's a link to those practice questions in the description. You can now watch something else. This.